Hello my wonderful students, you are welcome to a new lesson. Today I shall be teaching you logical reasoning, and by the end of this lesson you should be able to determine the validity of an argument. Sit up, learn and enjoy. You are welcome once again to the second part of the topic logical reasoning. Today we will be learning about the validity of an argument. From definition, an argument is a list or set of statements or propositions which are P1, P2, P3 and so on, called premises. It's also called hypotheses or assumptions, which lead to another statement or proposition, C, called the conclusion. We have two types of arguments. An argument could be a valid argument or an invalid argument. Let's learn more about the validity of an argument. Talking about the two types of arguments, let's take the definitions. A valid argument is one in which if the premises P1, P2, P3 and so on up to Pn are all true, the conclusion C will always be true. That means that an argument is valid if the conjunction of the compound statement is a tautology. On the other hand, an invalid argument or a fallacy is an argument that is not valid, in which all the premises and conclusions are not true. That means that an invalid argument or an argument that is not valid is so if the conjunction of the compound statement is either a contradiction or an inconsistent statement. I hope this idea is clear to you. Moving forward, let's know the different ways we can determine the validity of an argument. The validity of an argument can be determined by using any of these three methods. Number one, using Venn diagram. Number two, using chain rule. While number three, using truth table. Let's know more about using Venn diagrams. Now, the way we draw the Venn diagram for set theory is similar to the way we draw the Venn diagrams for logical operations from the table given before us, such as the Venn diagram for set ABC is similar to the Venn diagram for propositions PQR. The Venn diagram for intersection is similar to the Venn diagram for conjunction. The Venn diagram for union is similar to the Venn diagram for disjunction, and so on in the table before us. Please take note of this table for Venn diagram, the way we draw the Venn diagrams for logical operations. Also, knowing something about chain rule, the chain rule states that if we have premises P1, P2, P3 and so on, and the conclusion C, so that premise P1 implies premise P2 and premise P2 implies premise P3 and so on until the ending of the process where the last premise Pn implies the conclusion, then we can have a chain as the first premise P1 implying the last conclusion C. If it happens this way, the argument is a valid argument. Otherwise, if it doesn't happen this way, we say the argument is invalid or the argument is not valid. I hope these ideas they are clear to you. Let's take some questions. Question 1. Let's use Venn diagram, chain rule, and truth table to determine the validity of the following arguments with premises P1 and P2 and the conclusion C. The first premise says all bus drivers B are men M. Second premise says Okafor X is a bus driver, while the conclusion says therefore Okafor is a man. The solution by using Venn diagram goes like this. In the Venn diagram, let the universal set be all people. Of course, B represents bus drivers, M represents men, X representing Okafor. From the diagram, premise 1, all bus drivers are men. That means the circle for bus drivers is inside the circle for men. That's an implication. The premise 2 says Okafor X is a bus driver. That means X is inside the circle for B, bus drivers. Let's determine if the conclusion is valid, which says therefore Okafor is a man. From the Venn diagram, since X is inside circle B and B is inside circle M, the conclusion is true because from the diagram Okafor is a man. Therefore, the argument is valid. Let's solve the question 1 again using chain rule. From chain rule, the first premise, writing the first premise in logical symbols, you have B implies M because bus drivers are men. Second premise, X implies B because Okafor is a bus driver. The conclusion, X implies M because Okafor is a man. Now, chaining the premises in line with the conclusion, we can say that X implies B, then the ending of the B begins the second statement, B implies M. Chaining the premises. A chain is made up of rings in which the ending of the first ring begins the second ring. The ending of the second ring begins the third ring, and so on. So, trying to chain the premises in form of a chain and see if the links will go continuous, and comparing with the conclusion X implies M, we can see that the conclusion follows from the premises because X implies B coming from the second premise and B implies M coming from the first premise. So in conclusion, X implies M as a shortcut. In this way, the argument before us in question 1 is a valid argument using chain rule. Solving question 1 again using truth table. Here, what we are going to do, we are going to construct a truth table for the argument P1 and P2 implies C. P1 and P2, that is the first premise in conjunction with the second premise, implies the conclusion. Below here is the truth table we need. Of course, P1 is B implies M, P2 is X implies B, and C is X implies M. So forming the truth table as shown below, P1 and P2 implies the conclusion. We can see that the final answer is always true. The final answer for P1 and P2 implies C is always a tautology. So in this way, the argument is valid using truth table. The argument in question 1 is valid using truth table. We have solved question 1 using all three methods: Venn diagram, chain rule, and truth table. I hope this question 1 is clear to you. Let's take a next question, which says use Venn diagram, chain rule, and truth table to determine the validity of the following arguments with premises P1, P2, and conclusion C. The first premise says if you like mathematics M, then you will like economics E. Premise 2 says you X do not like mathematics. The conclusion says, therefore, you do not like economics. Let's solve question 2 using Venn diagram. From the Venn diagram, let the universal set represent all people. Of course, M represents people who like mathematics, E represents people who like economics, and X is you. From the question, premise 1 says, if you like mathematics, you will like economics. That means the circle for mathematics M is inside the circle for economics E. Premise 2 says, you, X, do not like mathematics. That means X is not inside the circle for mathematics. It's outside the circle for mathematics. That means X could be inside the circle for E, economics, but not outside the circle for M. X can also be outside the circle for E, which is economics. From what we can see, since X is not inside circle M, it follows that X may be inside circle E or outside circle E. Therefore, the conclusion which says you do not like economics is false and does not follow from the premises. Hence, the argument is invalid. The argument in question 2 is invalid using Venn diagram. Solving question 2 again using chain rule. The first premise written in symbolic form, M implies E. The second premise, X implies negation M. The conclusion, X implies negation E. Now from the chaining, you can see that chaining the premises in line with the conclusion, it is not working, because the first premise there says X implies negation M, and the second one is M implies E. You can see that the first one there, negation M, is not the same thing as this beginning of the second one there, which is M. So the conclusion which says, therefore, you do not like economics, is false. The conclusion is false and does not follow from the premises. Hence, using chain rule, the argument in question 2 is invalid. Once again, invalid. Let's solve question 2 lastly using truth table. Now, the truth table we are to construct is the truth table for P1 and P2 implies C. The first premise in conjunction with the second premise implying the conclusion. Now, if you draw the truth table, you will see that the final answer is a mixture of true and false. For P1 and P2 implies C. The final answer is inconsistent. That means that the argument in question 2 is invalid once again. So question 2 is invalid no matter the method you use. Question 2, the argument is invalid. The truth table is inconsistent. Let's take a third question. Let's use Venn diagram to determine the validity of each of the proposed conclusions S1, S2, S3 if the premises X, Y, Z of an argument are premise X, teachers T are contented people C. Premise 2, premise Y, which is X, every doctor D is rich R. Premise Z, which is no one who is contented is also rich. Now the proposed conclusions are S1, no teacher is rich. S2, doctors are contented people. S3, no one can be both a teacher and a doctor. Let's see the solution to this question, of course using Venn diagram. Now this is the Venn diagram. From the first premise X, teachers are contented people. That means the circle for T is inside the circle for C. The second premise Y says every doctor D is rich. That means the circle for D is inside the circle for R. The third premise Z says no one who is contented is also rich. That means that the circle for C is not having any business with the circle for R. There are two disjoint circles because no one who is contented is also rich. There is no intersection between the circle for C and the circle for R. They are two separate and disjoint circles. Now, talking about knowing if the conclusion is valid or not, the first conclusion S1 says no teacher is rich. From the diagram, of course, S1 is true, because from the diagram, the circle for T, teachers, has no dealing with the circle for R, which is rich. So the intersection of T and R is an empty set. So the first conclusion is valid. The second conclusion, S2, which says doctors are contented people, that second conclusion, S2, is false. And that makes the second conclusion invalid. Because when we say doctors are contented people, of course, from the Venn diagram, the circle for D, doctors, is not having any dealing with the circle for C, contented people. There are two disjoint and separate circles. So S2 is false. That makes S2 invalid. The last conclusion, S3, which says no one can be both a teacher and a doctor, is true. Because of course, from the Venn diagram, the circle for T, teachers, and the circle for D, doctors, they are two separate and disjoint circles. So no one can be both a teacher in circle T and a doctor in circle D, because the intersection of T and D is an empty set. I hope all three questions are clear to you. Thank you very much for going through the lesson today. I want to advise that you read your textbooks for more information. Don't forget to attempt your quiz and do your assignment. Hope to see you again in our next class. And until then, it is goodbye for now. Thank you for learning today.